Okay, this video is going to go over something called the discriminant. So if you remember the quadratic equation, the quadratic formula, it looks like this. This part right here is called the discriminant. This b squared minus 4ac part is called the discriminant. So what's going to happen is you're going to have a couple situations. Sometimes it'll be like 0. Sometimes it'll be like a perfect square, like 25. Sometimes it'll be just a weird number like 11. And sometimes it'll be negative. Based on whatever happens here, you can tell a lot about the equation. So let's do as if it was root 0 first. Well, really, it's not even, the root's not included. Just imagine like a square root symbol over these numbers. But if your discriminant is 0, your roots are real, equal, and rational. Meaning, if you think about it, it's like plus minus root 0, which is like plus minus 0, which means you don't have two answers there. You only have one answer there because like plus 0 is the same thing as minus 0. So you're only going to have one answer there, and it's going to be like an actual value, like 4 or something for that x-intercept. The next situation would be if it was positive. So like if it was 25, or if it was like 7 or something, or even like you could do 20. There's two situations that happen here. If it's positive, first of all, it's real. So whether it was red or green, it's going to be real. But the thing is, if it's a perfect square, it's rational. If it is not a perfect square, like say it was root 7 or root 20, which is like 2 root 5, it's going to be irrational. And then lastly would be like if it was a negative number, like -7 or negative anything really. These are going to be imaginary. And if you think about it, it'd be like root -7, which means you would have to take an I out. That I stands for imaginary. So just kind of keep that in mind. So based on whatever that discriminant is, we can kind of know a lot about the equation. So let's look at some examples. You're going to be running b squared minus 4ac for all of these. So what that's going to look like on this particular problem would be like 3 squared minus 4 times a is 1 here, times c. So this is really like 9. You really need to watch your negatives on this part. That's where most students mess up. So this is -4 times 1 times -10, which is plus 40. So that's 49. So it's positive, which means it is real. And it's a perfect square. 7 times 7 makes 49. So that means these are rational. These roots are real and rational. Okay, let's look at the next one. b squared minus 4ac, so that's like 6 squared minus 4 times a times c. So that's 36 minus 36, which is 0. Since it's not negative, that means it is real. And these, since it's 0, they are equal, and it is rational. The only time it's going to be irrational is if this number right here is not a perfect square, like 7 or something. Let's look at the next example. b squared would be like -3 squared minus 4 times a times c. So that's -3 squared is 9 minus 16 here, which makes -7. Since it's negative, that means it's going to be imaginary. Oh, and one more thing. If it's red here, if it's a perfect square, that means you could, like this one right here, 49 is perfect square. That means you could have factored this trinomial to begin with. If it's not a perfect square, that means you can't factor it to begin with. So like this one, you could not have factored. And if it's like 0, that means you could have factored it as well. Like this one is factorable. I know I'm kind of jumping around. I'm sorry. Let's keep moving. All right, in order to do the discriminant, you have to make it equal 0. So you have to look at this problem and add 5 and then rewrite it. So like 3x squared plus 6x plus 5 equals 0. Now you can do the discriminant. So b squared minus 4 times a times c. That's 36 minus 60, which is -24. So this one's going to be imaginary. Okay, number 5 here. The discriminant would be b squared minus 4ac. So that's 9. This -4 times 1 times -28 is going to turn into a plus 112. So this is 121. 121 is a perfect square. That's 11 times 11. So since it's a perfect square, that means these are real rational. Remember, it's only irrational if it's like 7, something not a perfect square, 11, 13, some of those numbers. Okay, and then this last one, the discriminant would be b squared minus 4 times a times c. So that's 16. -4 times 3 times -2 is plus 24. That's 40. Okay, it's a positive number, which means these are real, but it's not a perfect square. So that means these are going to be irrational. Because if you broke down root 40, that'd be root 4 times root 10, which is 2 root 10. That's irrational. So if I were you, I would study this right here and know the different situations that you're going to be put in and what the roots are going to be doing based on each situation. Hope this video helped.